So now we kind of understand a little bit about squash and stretch and how it works, but I want to go over quickly just a couple of mistakes that I see a lot when people first try to start using squash and stretch. All right, so one of the key things of using squash and stretch correctly is to keep the volume of the object looking roughly the same, no matter how squashed down it is or stretched out, all right? What I see typically with students is something like this right here, okay? And we'll take a look and see what it looks like, all right? So a student will be doing a squash, all right? And they just squish the object in the Y direction just by controlling it like this. And they go, okay, here it is. Now I'll squash it down. There's squash. However, this is not correct, all right? And the reason why is because if you take a look at our original sphere, okay, just imagine this as a water balloon full of water, okay? Now we take a look at this original sphere and we can see, we can kind of imagine how much water is inside of that water balloon right now. Now if we take a look at this one, this looks like it can hold about half as much water, all right? It doesn't look as big as this one. This one looks like it's gonna get somebody a lot more wet than this one. If I were in a water balloon fight, I would want this one. Now, how we fix this is to make sure that not only do we squash this down in Y, but anytime we squash it down, that mass has to be displaced, all right? So that water volume needs to go somewhere. It can't just disappear or fizzle out into the universe. It has to go somewhere while remaining inside of that water balloon, okay? So if we're pushing down on it, the only place for it to go then is outwards, all right? So whenever we scale an object like this down in one direction, it will have to scale outwards in the other two directions, all right? So in this case, we're squashing it down in scale Y. It'll need to grow larger in scale X and scale Z to account for that displaced mass, all right? So, if you take a look, this water balloon is clearly bigger than this one, all right? But this one is probably about the same size as this one. This one is just being squished down, okay? Works the same way with stretch. So oftentimes I'll have students stretch out an object, okay, just by moving that Y handle. Now in this case you can see that this looks much more massive than this right here, okay? So this is our original water balloon. This is just scaled in Y, all right? Looks pretty big, so it has magically grown in size, all right? This one, on the other hand, is roughly the same volume, okay, as the original one here, okay? And that's because not only have we stretched it out in the Y direction, we have thinned it down in the X and Z directions, all right? So we've scaled it inwards. So just remember that whenever you are working with squash and stretch, keep in mind the mass or the volume of the object that you're working with. It'll be very confusing for the audience, and they will pick up on it if your object seems to be magically shrinking in size or growing in size, all right? It should be able to deform and squish and stretch, but it should always retain the same volume, all right? So now that we've gotten that out of the way, we're going to go over the steps for you guys to create your own bouncy ball, all right? And we'll go from this to this, and it'll be great. So let's get started.